A guy out on the West Coast named Jim Brown took up my work where I stopped on noise and sound systems. And he did a big, long research project on microphones and pin 1 problems in microphones. And they used a cell phone. They had a trailer, a motor home, and they would park it in front of a local radio station that had AM and FM on the same stick. And they went through all these measurements to find out which microphones picked it up and which didn't, and they changed mic cable and all the yada, 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 all that stuff. And out of that came this paper, which I'm pretty sure the AES has published already. It's at least available on a preprint. And what it clearly shows is that how they connect pin 1 to the frame of the microphone is going to determine whether it's going to have a problem or not. And most of the microphones, that the legacy microphones anyway, that maybe came out before 05 or so, have got internal problems that the manufacturers never knew anything about. Pin 1 should go right straight to the case at the connector. And especially on condensers, there would be a wire which went in and went somewhere and finally hit the case. But if you're bombarding the mic cable with RF and you got that's a re-radiator. And so now if the amplifier inside is sensitive to that stuff, you're going to hear it because it's just demodulating it like a radio would. A couple of things you can do. This is all the cable I have is star quad, which is the only way to fly. If you have that kind of a problem, star quad also has a very good shield. Swap out the cable if you're not using star quad and see if that makes a difference. And then, something I don't like to recommend, but if you're using a metal-barreled switchcraft female XL going into the mic, you can take the shield and tie it to terminal 4, which is the shell contact in the plug. All right, and what that does is that bonds the shield to the outside of the microphone right there. Now you have a bastard cable. So what I recommend doing is you take a 6-inch jumper with a regular wired XL on the male end and this modified female on the other end. And if you think you have a problem, see if the problem goes away if you get rid of the pin 1 issue. I mean, that's a piece of wire and 2 XLs. On the switchcraft, now you can't do this with any other XL. It's a switchcraft, which is a metal. You know, they have 3 little spring-loaded ball bearings. Yeah. So they make real good contact with the mic shell, the housing. And that 4th terminal is, once you tighten down the mounting screw, you know, it's a backwards thread screw. All right, once you crank down on that 4th terminal is now connected to the case via the 3 spring-loaded ball bearings. And now there's another thing you can do. Neutrik has come out with a line of connectors, both male and female, that have a very sexy combination ferrite and capacitive bypass right inside the connector. I can't call the product name right now, but it's gotten quite a lot of press. And if you have a high RF situation, those things are terrific for getting rid of it. All you do is make up some 6-inch jumpers with that newfangled plug on the microphone side of things. And most of the time that'll stop it. And their test was you take a cell phone and you hold it up like that. You know, I mean, the peak power output of a cell phone is several watts.